Hi there. Let's talk about converting back and forth between binary and hexadecimal. Why would you want to do that? Well, maybe you're in computer science. Maybe you've been presented with some numbers that you need to convert. Maybe you have like a bunch of ones and zeros. Maybe you have like a OX and then something that looks really weird. It's got some letters in it, but it's also got some numbers. And you're trying to figure out what are these? What are we trying to convert back and forth between? You should have watched my other videos by now, which will teach you how to convert back and forth between both of these number bases and decimal, so you can understand what they are in just normal human terms. But as a quick recap, decimal is a base 10 number system because we have 10 possible characters that we can use. We can say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 10 total characters, 0 through 9. We also have binary, which is what computers use, which is a base 2 system. It's base 2 because the only characters you have available are just 0 and 1. So base 2, 2 characters. You can represent a number between 0 and 1 in a single digit. Then we have hexadecimal, which is a way to represent a number in a more compact way. We call this a base 16 number system there because we have 16 possible characters. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, just like decimal. But then we add more numbers. We add like 6 numbers. We say A, B, C, D, E, F. And what happens is the A has a strength of 10, whereas the 9 just to its left had a strength of 9. The A has a strength of 10. The B has a strength of 11. The C has a strength of 12. And the D has a strength of 13. And the E has a strength of 14. And the F has a strength of 15. And so, we just have more characters that we can use in one single digit, which means we can represent the same number in decimal, but just we can represent it smaller if we use hexadecimal. So it's kind of useful when you're working with computers. Oftentimes you'll be presented with the choice of looking at bits in binary or hex and not necessarily decimal, because binary, as you're going to learn in this video, gives you kind of a good idea just by looking at it after you've practiced a little while. It gives you a good idea of what hex numbers you would be seeing if you were looking at the same number. And vice versa. If you're looking at hex numbers, if you look at them a lot in your daily life, you'll start to kind of like see through the matrix and you'll realize, oh, that's a 1011. And if you're interested in finding what bits are on and off, it's convenient to be able to look at a hexadecimal number and kind of intuitively know, okay, those bits are probably like on and off, those bits are all on, whatever. So this is the basics of number bases. Here's a trick. In all my other videos, when we converted back and forth between decimal and binary and hex and all that stuff, we used multiplication, we used division, we messed with the numbers quite a bit. The great thing about binary and hex conversions is you don't even really need to do math. Maybe a little math at first while you're learning, but eventually when you get used to it, you start to realize you can memorize short patterns. Let me bring your attention to the fact that in hexadecimal, you have 16 possible combinations, or you can represent a number from 0 to 15. In binary, you can do the same thing in 4 characters. If I had 4 characters right here in binary, very quickly you could do the calculation in your head. If you've watched my other videos, you can see, well, that 1 counts for a 1, and this 1 counts for a 2, and this 1 counts for a 4, and this 1 counts for an 8. If I want to know what the maximum value is that I could represent with 4 digits, I just take the top number's strength, multiply it by 2, and then subtract 1. So if we have 1, 2, 4, 8, I'll just multiply 8 by 2, that's 16, and then subtract 1, that's 15. So I can represent a number between 0 and 15 with 4 binary digits. But I just said you could do that with 1 hexadecimal digit, right? So that means 1 hexadecimal digit is actually 4 binary digits. And if you just memorize 16 combinations of numbers, which is not like that hard, and even if you don't memorize them all, I don't have them all memorized, it's really easy to convert in your head a 4-digit binary number to decimal and then convert that back to hexadecimal pretty fast, hexadecimal. So what's the equivalent of 1111? Well, we know it's the highest possible value with just, one hexadecimal digit. So that would have to be an F. So you can memorize already, a couple of really, really easy combinations. We could say, let me say 0 binary, OB, to say that we're looking at binary, is equal to 0x F, so just the letter F in hex. Remember that we like to prefix different base number systems to give the reader a reminder of what base they're looking at, because if we just put, for instance, this top one, I'm going to say that 0000 in binary is just 0 in hex. If I didn't put that prefix, how would you know if you're looking at hex or binary or decimal? It would be even more confusing if you had like, 120. Is that hex 120 or is that decimal 120? I guess it can't be binary 120, but if we did 110, now it could be binary or hex or decimal. So I'm just going to put 0B for binary, and I'm going to say it's 0. So that's 2 of the 16 total possible combinations that we would memorize. So let's iterate through all the combinations. Just for the sake of making this table more compact, actually, let me start a new little notepad page here. I'm going to omit those prefixes because those are a good idea, but while we're doing our lookups, they're a little irritating, so I'm going to take them out. So I'm going to say 0001. I'm going to say this. So I'm just going to count from 0 to 15 in binary. So this is going to be 1, 1, and then 0, and then 0, 1, 0, 1, 0, 1, 1, 0, and then 0, 1, 1, 1, and 1, 0, 0. And then I think I can just like copy this whole thing down here, and then just change all those zeros to ones. I could have been doing that at each sub-step up above if I wanted to, but I don't know, that's a lot of copy pasting. Let me just double check here that I'm doing this right. I should have 16 lines. I don't, so I've done something wrong. Let's see. So this is like 0, 1, 2, 3, and this is 4, this is 5, and then 6, and then 7, and this is 8. Oh, I have that twice. Okay, 8. And then since I copy pasted the bottom part, I think I can probably assume that's okay. 1, 2, 3, 4, 5, 6, 7. That was kind of spooky. I guess lesson learned is that relying on a battery pack for a light that's going to stay on for many hours is probably a dumb idea. Anyway, continuing, we have this table here. We have like 16 possible combinations. So now I'm going to map these to hexadecimal digits. The first, like 10 are going to be really easy, right? It's just going to be 0, and then 1, and then 2. You can make a vertical table if you want for yourself. I'm just doing it this way because it's easier. The way that I'm typing in this notepad. So I'm going to do 7, 8, 9, and then when we get to 10, let me just double check that this is actually a 10. So this is 8 plus 2, so that means this is indeed a 10. And, 10 in hex, not decimal, so that's A. And then B, and then C, and then D, and then E, and then F. Okay, so now that we have this little table set up, if you want to write it horizontally, that's fine. It's actually really, really easy to convert back and forth between binary and hex now. Imagine we have a gigantic hex number, 0x, and then I'm just going to do like a bunch of numbers, and then I'm going to change some of these to like letters, just to make things more interesting. A, B, C, D, E. Did I use any D's? E, F, A, B. I didn't use a B. There we go. And I'll put like another 8 in there. Okay, so this is huge, and this would take like a while to calculate, right? If you were going to convert it to decimal. For hex to binary conversion, it's actually pretty easy. You literally just go B. What is B? B is that. So B is just that. You don't even have to do any math. Let me copy paste this down here so I can show you a really easy way to do this. Every digit, I'm just going to line it up. So D is this right here. So I'm going to say the D is that. And then the 6 is that pattern right there. So move you over. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Maybe that'll line up later, hopefully. So the 1 is pretty easy. Probably didn't even need to copy paste that. I could have just like looked at it and typed. The E is going to be that, and the 7 is going to be that, and the 2 is going to be this, and 8. See what I'm doing? I'm literally just copy pasting the bit patterns. If you don't have copy paste when you're doing your conversion, that's okay. You can at least write down zeros and ones really fast if it's just, 4 at a time. I should also point out that, this is pretty important to remember. It's kind of like a good term that people like to use. 4 bytes or 1 hexadecimal digit, it's called a nibble. So usually you're used to seeing 8 bytes in a row and you call that, usually you're used to seeing 8 bits in a row and you call that a byte, or 2 hex digits in a row and you call that a byte. If you just see 4 bits or 1 hex digit, that's a nibble. 2 nibbles make a byte. Try to remember that. So we have this giant thing here. We have literally now successfully converted binary. I'm just going to put OB here and then remove all the spaces. This is the binary number that we originally had in hexadecimal. So again, just to emphasize, these are the 2 same numbers. They're just represented differently. Let me punch this into my personal calculator to make sure that I gave you the right walkthrough, so I don't have to correct in a video later. So expression x result binary. Oh God, I can't even read that. Okay, so let me do it backwards. I'm gonna copy paste this one in there. Okay. So I'm gonna say hex. Okay, so it's telling me that I'm supposed to get to B and then a D6, 1E, 72, 8FAC. Okay, so I did it. And this is also a good reminder that you kind of want to pair off into groups of 1 byte at least. So, each 2 characters, that's 1 byte. One character by itself is a nibble. So you want to pair off into bytes. And notice how this B is all by itself. So you want to pad to the left with a 0 so that you're just kind of working with bytes. It's easier on the eyes and the brain. And you'll usually see something like this if you're reading output from a program or something. In fact, you might see something like this representing, here's a word, or you might see something like this, showing that this is like a D word or, like a 32-bit number. And if we wanted to say, oh, this is a 64-bit system, so let's look at 64 bits, let's look at 8 bytes, then we'll just like pad it with, let's see, 1, 2, that's 1, 2, 3, we'll pad it with a bunch more zeros. 1, 2, 3, 4, 5, 6, 7, 8. So this is a proper 64-bit number or an 8-byte number that works with modern systems, whether you have the space in there or not. And so I'm not going to do another example from hex to binary. Let's do a quick example from binary to hex. It should be just as easy. So I'm going to start a new tab here and just copy paste the table that I made. And then let's make a bunch of random numbers for binary. And so now we've got like a bunch of numbers. All we have to do is, I'm going to copy paste this so I don't ruin the original thing that I wrote down. And I'm just going to break it up into groups of 4, starting from the least powerful digits, like all the way on the right. So I'm going to go doop, doop. Okay. So after breaking it into groups of 4, you can see that the most powerful digit there is a 1 all by its lonesome. I could put 0, 0, 0 to make sure that they're all groups of 4 bits. I don't really have to, because I could still kind of understand just by looking at the 1 that it's going to end up being a 1. And then literally just translate it the same way I did before. Okay, that's a 1. 1010, that's an A. What's 1001? It is a 9. What's 0100? That's a 4. What's 1010? A. What's 1001? Didn't I just do that? That's a 9. What's 00010? That's going to be a 2 for sure. Yeah, 2. I finally got one off the top of my head. 1011, that's a B. And then basically 15 minus 8. I don't really want to work that out of my head right now, so I'm going to look at the table. 7. Okay, I guess I should have done that. Easy, right? Like, how fast was that? So I'm just going to copy paste these, put an OX in front of it, and maybe bunch them into groups of 2 first to see what's up. Okay. So they're not in groups of 2. That means this one is kind of, I should have started grouping them on the right side, kind of messed it up. So I'm going to just, rearrange the grouping. And so this is the resulting hexadecimal number. Let me punch this into my personal calculator to make sure that I got this right. Actually, let me do this original number here. I'm going to say this binary number is supposed to be 1A94892B7. Okay, we did it. Really easy, right? So every time you have to convert back and forth between binary and hex, it's your lucky day, because that's like one of the easiest conversions you could do. Thanks for watching this video. I hope you learned a little bit of stuff and had some fun. I'll see you in the next video. Hey everybody. Thanks for watching this video again. From the bottom of my heart, I really appreciate it. I do hope you did learn something and have some fun. If you could do me a small little favor, could you please subscribe and follow this channel or these videos or whatever it is you do on the current social media website that you're looking at right now. It would really mean the world to me, and it'll help make more videos and grow this community. So we'll be able to do more videos, longer videos, better videos, or just I'll be able to keep making videos in general. So please do me a kindness and subscribe. Sometimes I'm sleeping in the middle of the night and I just wake up because I know somebody subscribed or followed. It just wakes me up and I get filled with joy. That's exactly what happens every single time. So you could do it as a nice favor to me, or you could troll me if you want to just wake me up in the middle of the night. Just subscribe and then I'll just wake up. I promise that's what will happen. Also, if you look at the middle of the screen right now, you should see a QR code which you can scan in order to go to the website, which I think is also named somewhere at the bottom of this video. And it'll take you to my main website where you can just kind of like see all the videos I published and the services and tutorials and things that I offer and all that good stuff. And if you have a suggestion for clarifications or errata or just future videos that you want to see, please leave a comment. Or if you just want to say, hey, what's up? What's going on? Just send me a comment. Whatever. I also wake up for those in the middle of the night. I wake up in a cold sweat and I'm like, it would really mean the world to me. I would really appreciate it. So again, thank you so much for watching this video, and enjoy the cool music as I fade into the darkness which is coming for us all.